but it's okay. I think a lot of you are confused. So let's make this bigger. Okay, so I told you you could make x as a positive or x as a negative in your calculation. Why is that? Because the direction is completely arbitrary. I mean, the sign of your direction is completely arbitrary. For example, I told you going to the right is a positive. Oh my god, I can't make it straight. Going to the right is positive. How do I know this? I just made it up. But remember, your x-axis and your y-axis is like that. Oops, tak masuk dah pula screen. Your x-axis is like this and y-axis is like that. So based on this, I said, okay, let's just say this is positive and this is positive. But this is actually completely arbitrary. We made it up. So when I say I want to say going upwards is positive, or when I want to say going to the left is positive, I can also say going to the west is positive. In my calculation, it completely depends on me, on how I want to define it. Now let's see for this example. Let's say my x is, let me erase that. Delete. Okay. Let's just make this non-intuitive. Usually we say going down is negative, right? Let's just say x is going down and it's a positive. I define going down as a positive for this time. This is completely depending on me, okay? So I said, okay, going down is positive, which means that going up is negative, okay? It depends on me. I am the one who defined this direction. So if x going down is positive and x is 2 centimeter, we already calculated this part. It is going down by 2 centimeter. It's stretched by 2 centimeter. The spring stretched by 2 centimeter, and that is your delta x. I stretched my spring and it extended by 2 centimeter. Okay, so my k constant value is 150 Newton per meter. So let's put that in. Force is equal to minus my value of k is 150 Newton per meter, and my stretch in spring is 2 centimeter. And I have to convert this to meter because this guy is in meter. I can't put a centimeter in an equation with a meter. So this becomes 0.02 meter. Is that right? Did I convert that right? Hello? Okay. Just checking. I don't want you guys to be asleep. Okay. So meter can be cancelled out with meter. If I put this centimeter, it can't be cancelled out. So always convert for it to become standard. Okay, so 150 times 0.02. Let's see what that is. Even though I already calculated it, I forgot. So that is a 3 Newton, and there is a negative sign, right? Okay, let's erase this first. Okay, I always put it in random places and then ending up having to erase. Okay, so it becomes 3, but I have a minus sign here, so it becomes a minus 3 Newton. I said going down is a positive and going up is a negative, right? So from my answer, what can I say about the direction of force? Can anyone answer me? What can I say about the direction of force? Is it going up or is it going down? It's going upwards, right? Because it's a negative. I defined it like that. Okay? So does this make sense? If I switch the sign, this equation, okay, let's say I say going down is a negative because it's more intuitive like that, and going up is a positive. This is what we are more used to. So F is minus, that minus is still there because it's part of the equation, 150 Newton per meter. minus 0.02 because your x is going downwards and we said downwards is a minus sign. So my answer is actually a positive 3 Newton. And what can I see about the direction of the force? It is going upwards. No, it's going upwards because I'm using this convention now. Green with green, red with red. So it doesn't matter what your answer is. It completely depends on how you define where your positive and negative is. Is that clear? Am I going too fast? Okay ni dah repeat tau. Ni bukan benda baru. Okay. Next one. Multiplication of vectors. Multiply a vector quantity. Multiply a vector quantity with another quantity. Let's say, okay, we have come to Lutfi's question. Lutfi Al-Hadi, forgot your name. Vector F with, okay, vector F with vector S. S is displacement or distance. But in this case, it's the displacement. So when you have a dot product, okay, this guy is called a dot product. When you have a dot product of two vectors, it becomes a scalar quantity. That is why work done is not a vector. On the other hand, if you have a cross product, this guy is called a cross product between two vectors, between the vector R and between the vector F, you get a vector. How do I know it's a vector? I have this guy over here, the unit vector. Okay, again, the dot product will always give us a scalar, even though it's a multiplication between two vectors. The cross product will give us a vector product. And we multiply two vectors by the cross product. Okay, so what is a cross product and what is a dot product? Okay, baru introduction. So dot product, what you have to remember is scalar, and cross product is vector. Sekejap, padam dulu. Okay, so that is why your work done is a scalar. So where did we get this cosine? Okay, so expanding the dot product gives us Fs times cosine theta. Theta is the angle between vector F and vector S. Similarly, it can also be expanded like this for the cross product R, F, sine theta, where theta is the angle between R and F. So let's see more on this. Okay, so I said AB, you just multiply it like usual, times with cosine of theta. Theta is the angle between vector B and vector A. This is fairly straightforward. But why does it make a scalar? Why does it make a scalar? Does anyone know? Does anyone know? When do we use cosine? What quantity are we trying to find when we are using cosine? Are we finding the opposite or the adjacent? Are we finding the opposite or the adjacent? Adjacent, right? Okay, so when I am trying to find the component of B that is adjacent to A, that is why I need to find the B cosine. So this guy becomes Bx, By. So B cosine gives me Bx, right? Bx is in the same direction as my vector A. So for this equation to work, my A and B has to be in the same axis. It doesn't matter which axis, it can be X, it can be Y, but they have to be in the same axis. But we will talk more on this about the axis, but for now you need to know that they need to be in the same axis. For example, in the x-axis. Okay, so imagine A is in the x-axis. I need to find vector B that is also in the x-axis. How do I find this? B cosine theta. And then I get this equation, AB cosine theta. Why is it a scalar? Because when you are in the same direction, you no longer care about the direction, right? When you are going in the same direction, you already know, oh, this guy is in the same direction as me. Why should I care where he's going? He's always going to be in the same direction as me. So it becomes a scalar where direction doesn't matter anymore. Direction does not matter because both of these guys are in parallel. That is why you have a scalar quantity. Okay, scalar does not have direction because they are going in parallel. Okay, is that clear? Is that okay? Okay. Next one, multiplication of vectors, a cross product. Okay, so this is a little bit harder to explain. But again, the cross product of two vectors give you another vector, which means that there's another direction associated with the result. So how does this look like? Let's see. Cross product. Okay. So two vectors can be multiplied using the cross product. So I'm having a cross product between A and B. The answer is, it's like this. Using your right hand rule, I don't know if you guys have learned this before. Using your right hand rule, your thumb, or yeah, I think so. Wait, let me check if it's your thumb. Oh, it doesn't say. Okay, but basically it's your thumb will point in the direction of your cross product vector. So A and B gives me a vector in this direction, whereby it makes a 90 degrees angle with the vector A and 90 degrees angle with the vector B. Okay, this can also, that's the direction. The magnitude of this guy, of this A cross B, is given by this equation, AB sine theta, where theta is the angle between A and B. The direction is given by your right hand rule. A is your thumb, B is your middle finger, A is your pointy finger, B is your middle finger, and your thumb is the A cross B direction. Okay? Ni senang je tau. Kita nak je laju-laju je. Chapter 2 is harder, so I'm going to focus on that today. So dot product between vectors. Work done, F dot with S, magnetic flux, B dot A, both are scalars, and cross product of vectors, torque, magnetic, angular momentum. You don't have to memorize this. It's just an example. Okay, so let's take a look at this problem example. The work done on an object by force F. Okay, force F is this guy. Kita tunjuk. That moves with displacement S is defined as work done F dot product with S. So F is here. This is let's just say F1, F2, and this is F3. Calculate the total work done on an object that displaces a distance of 1.5 meter along a horizontal floor due to forces as shown. Okay, again, we have three forces, F1, F2, and F3. Calculate the total work done on an object that displaces a distance of 1.5 along a horizontal floor. So along a horizontal floor is on the floor lah, lantai. So it displaces, let's just say it goes to the right. So my S is going this way by 1.5. Okay, let's just say that. So find the total work done. Okay, can I have, because Lutfi asked me what work done, can I have Lutfi to figure out what is the total work done for force 1? Can I have Farhani for W2, work done number 2? Okay, senang je, tak payah panik sangat. Okay, and another person. Who is my lucky person? Who wants to volunteer? Nobody? Nobody wants to volunteer? Come on guys, it's easy. Nanti suruh yang susah-susah. Atira Izani, can I have you to do work done 3? And Arvin, total work done. Senang je, pakai formula je kot. Okay, work done number 1. Siapa? Lutfi. $60 cosine theta. What is your theta? 30. Okay, so that is your is this your F? F cosine 30. Okay, and then your S is dot product 1.5 meter. So kiranya equation yang Lutfi kasih ni dah terus dot product lah kan? Betul tak? That you already expanding the dot product, because in its original form it should be F dot S, right? Betul tak? This is the original form. Lutfi expanded it, so it has a cosine now. Okay, so let me write that nicely balik. Okay, macam ada bela-bela je lagi. Okay, so F1, because we are calculating work done for force number 1, F dot product with S, which is your displacement. This becomes F1 S cosine 30, whereby this guy, theta, is the angle between F1 and S. Betul? Okay, so what is the answer for this guy? 60 times 1.5 times cosine 30. $77.9. What is the unit? You sure? F is Newton, S is? Yeah. No, tak ada per, just Newton meter. Okay? Your F is Newton, your S is meter. There is nothing else. Cosine 30 does not have unit. It is unitless. So your answer is 77.9 Newton meter. Did everyone get that part? Okay, is it clear? Is it clear? Okay. Work done number 2. So this guy is missing another decimal point, 94. Okay, always 2 decimal points. Work done number 2. Who was it? Forgot. This is Arvin. This is Farhani. Farhani number 2 ke number 3? Farhani. Okay, Farhani. Okay. Okay. Number 3 siapa? Do you want to go first? Me tu siapa? I can't see you. Again? Saya tak dengar lah awak lagi sekali. So what's the equation that you should use? Work done number 3 is F Yep. Okay. Times. You mean dot? Or you want to expand it terus? Dot. Okay. S K equals to Sekejap 250. Sorry, 20. 20 kan? F tu awak. Farhani. Oh, dot. Nak dot lagi sekali. Okay. $50, 150. What is half a circle punya angle? Half a circle. 180, right? 180 is the angle. Okay, let's see. 180 cosine 100 of 80 gives me a -1. So this becomes, okay, this guy does not have the dot anymore because you already expanded it. Okay, let's just put it like this. So this is 20 times minus 1.5. It's a minus because it's going in the opposite direction as S. So betul, it's a cosine 180, which is the angle between F2 and the angle between S. So the answer is 20 times 1.5 minus 30 Newton meter. Is that clear? Yep. Oh, it's the angle between, remember I told you, okay, let's go back to this slide. I told you this formula, theta, is the angle between vector B and vector A. This is theta, right? Okay, let's go back to the example. The angle between F2 and S is here. Total. These are two vectors. Vector F2, vector S. The angle between them is theta. And we know that this guy is 90, this is 90, this is 180 degrees. Okay, if you already know it's half a circle is 180, that's fine. Just showing this if it's not clear to you. It's 180. Is that okay? Faham Faham Okay. So when we have a cosine of 180, it becomes a negative. Okay, you can use your calculator, find that out. It's a -1, which just means that the vector are in opposite direction. Okay, so your work done is negative. It has a negative even though it's a scalar. Okay, because it's a magnitude. Magnitude has positive and negative. Okay, it's just going either in the same direction or in the opposite direction. Tujuh. Okay, so that was W2. What about work done number 3? What's the equation first? F3 vector dot product with S, right? Okay. 250 Newton. Okay, good. 1.5 What's the angle? What's the angle? Putus-putus lah. Can you type that out? Saya tak dengar. Sorry. Okay, can you type that out? I can't hear you. What's the angle? Tu je. I just need the angle from you. $180. Why is it 180? 180 represents the angle between vector F3 and vector S, right? So let's draw it out. F3 is this way, your S is this way. What is the angle here? Is it 180? It's a 90, yes, thank you. It's a 90, eh? This is the angle for number 3. Is that okay, Atira? Izani? Do you see it? Do you see why it's a 90? It's a right angle, kan? Sini and here, it's a 90. Okay? So cosine 90 gives you a 0. What does that mean? It means that vector F and vector S can't ever be in parallel. It can't be ever in parallel because this guy is in the Y direction, this guy is in the X direction. They will not ever meet. They will not ever date. So it becomes a 0. The work done is 0 in that direction. Okay? So Arvin, can you give me the total work done? $49.94. And you got this by 77.94.47. Okay, thank you. Saya salah dengar. 47. Okay, so you got this 77.94. It's supposed to be plus, but it's a minus there. Yep. Plus a 0, right? So that is how you got the 47.94 Newton meter. That is your total work done. Okay, good job everyone. So the angle is very important. You need to know how to find the angle between the two vectors. If you are still having trouble with that, you need to revise. Okay, so this one is a little bit hard, so let's not do that yet. This one yet. We'll learn this in semester 2. So any questions for chapter 1 before we go to chapter 2? Yep. If it's in any quadrant, it still counts as positive. For you mean the work done number 3? Is that your question? No, cosine 90 yang 0 The angle when it's a 90, it means that it will never ever be parallel. I told you, kalau dot product, we always want the two vectors to be in parallel. If the vectors are like this, they will never ever meet. I cannot resolve them to be in the same direction. Kan? Kalau vector in the y-axis and vector in the x-axis, they cannot be resolved to be parallel. Tak boleh. Unless it's like this. Contoh. Faham ke? Faham Okay. Kalau vector A dengan B, yes, I can resolve A to be in the x direction. How? X is A cosine theta, right? But if my A is like this, tak boleh sebab cosine 90 is simply a 0, which means that it can't be resolved. They are at a right angle, you can't resolve them. So it will never ever be parallel, which so you can't get a dot product lah basically, so it's a 0. Okay, it's math, but it's basically math. The key thing that I want you to know here is that you need to know how to find the angle between the two vectors. When you plug in the right angle, you can get a 0, you can get a positive 1, you can get a negative 1, you can get whatever value that is, and it will give you the answer. You just have to know the correct angle between them. Okay, so take time to practice on that. So that was chapter 1. Don't save. Are we still recording? Yep, okay. So, yeah. No, for your tests and exams, you won't ever be tested on the American units. I guess for chapter 1, they just want you to be to know that there's another unit other than the SI. So for the exam, no. Okay? You're welcome. Okay, so starting with chapter 2. Chapter 2 is a little bit difficult compared to chapter 1. I'll try my best to explain. But as always, if you have questions, feel free to stop me in anywhere in my lecture. So for this chapter, we have translational linear motion, uniformly accelerated linear motion, free fall, projectile, and graphical representation. Okay, so your learning outcomes or the things that you will be tested on your exam or your assessment is you have to know how to define, calculate displacement, velocity, and acceleration. You have to use the linear kinematic equations for uniform acceleration. You have to solve for free fall problems and solve projectile motion problems. Actually, this chapter is my favorite because it deals with baling-baling bola. So I love it. You can simply see what's going on actually. Okay, so describes the relationship. What is classical mechanics? It describes the relationship between motion of objects in our everyday world, which is what I just said, and the forces acting on them. Okay, so I don't have a ball right now, but okay, this does not look like a ball. Let me find something that is round at least. I don't have anything round. Okay, let's just say this is a ball. Can you guys see me? Can you guys see me? Hello? Okay, so let's just say this is the ball. I will throw this ball like that, and we will determine what is going on with this guy that it falls back. What happens at the top? What happens when it goes down? What's the angle? What is the velocity? So that is what we're dealing with for this chapter. Okay, I have a velocity. I'm throwing this ball, and in mid-air it stops because, right, you can see it stopping split second, and then it goes down back again at a certain velocity. So we will try to solve for that. That is called free fall and projectile. Okay, so Sir Isaac Newton, everyone knows him. I don't need to explain more. Just Google him yourself if you're interested. Okay, kinematics, a branch of physics involving the motion of an object and the relationship between that motion and other physics concepts. Okay, that's a very general explanation that is not helpful at all. So types of motion, there is 2 types, I believe. Translational motion, which is the change in position. So let's say I am moving my phone like this. That is translational motion. I am changing its position. I am not rotating my phone. I'm just sliding it across my book. So that is translational motion, change of position. Linear motion. In translational motion, you have linear, you also have curvilinear. So linear motion is one-dimensional. Either you are going in the x-axis or you are going in the y-axis. And you also have two-dimensional, where you have an angle. So let's say I have my phone, it's going at an angle. It is going in the x direction upwards. It's going in the x direction positive. It's also going in the y direction positive. Those two components give me an angle. I'm moving my phone at a position with an angle. And then we have parabolic path. Parabolic projectile lah, basically. Projectile looks like this. If you have seen the video on Instagram, you will know that we will deal with something with a movement looking like this. Okay, so one-dimensional is I can't draw it one-dimensional. Okay, so it's going this way or this way or this way. sorry, one dimensional is this guy, this guy. This is 2D because we have we have y component here, we have x component here. Okay, forgive my drawing, it's really bad today. Okay, so let me just erase that first. Is everyone still with me? Are you guys sleepy? Don't be sleepy. I will call you out. Okay. So next one, types of motion. Repeated motion. Just now we talked about translational, whereby we are just moving it to a position. Either it's one-dimensional or two-dimensional, right? Repeated motion is like I don't have a ball. It's like rotation, whereby you change the orientation. The angle keeps changing. Or rolling, change of position and orientation. These two are different. Rotation and rolling are two different things. How? I don't have an example. I really don't have an example. Oh wait, I do. Let's crumple up this time. This guy. Okay. This guy is my ball. Okay. So, if it's rotation, I am just doing like this. It's rotating. It's not moving to a position, it's just rotating. Boring stuff. However, if it's rolling, it is moving while rotating. Okay, macam kita tolak bola lah. Kita tolak bola, tolak. It's moving in the x direction. It's also rotating. That is rolling. If it's just static here, but it's what do you call it? Rotating. So that's just rotation. Alright. And then you have simple harmonic motion, like your pendulum clock, the great grandfather clock, or whatever you call it. So that's a simple harmonic motion. And then you also have damped harmonic motion, whereby this is the usual case if your system is not ideal. Over time, the swinging becomes more slow. That's damped. And you also have wave motion, like your sinusoidal wave. Or you can just imagine a beach. This is me. I am at the beach. I see waves. So that's wave motion. Okay, so that's the simplest form of wave. Next. So translational linear motion, you always have to have a reference point, right? So let's say let's use a different, okay, this guy. So this is, let's say this is my y direction, my z direction, and my x. So my reference point will be my origin, and I will say, oh, with respect to the reference point, object A is 4 units in the z direction. So that's your position vector. Okay, so position vector, this is 0, 0, and your z is a 4, and this guy, let's say it's a 3. So this object B is, the position vector is 0, sorry, it's not a 0, this is an x, 3, 0, 0, right? And then let's say this is a 5, and I have an object C here. The position vector of this object is 0, 5, 0. Okay, so it's 5 units in the y direction, positive y direction, 0 in the x direction because it's on the axis, and 0 in the z direction because it's still on here. It's still in the 0 point of z. And the same case for here, 0 in the x direction, 0 in the y direction, but 4 in the z direction. So that is your position vector. It gives you detail on exactly where your object is. Okay, so this one is pretty easy. I think you've seen this one before. Just need to remember it again. So displacement. An object that moves means that there is change in position, obviously. So it defines a vector that represents the motion of a particle between 2 points. Displacement is always the shortest distance. Always. always the shortest distance. Okay, so this top guy is my distance. I am Ali. I am riding my bike at a distance of 10 meter. But Nadia is smarter than Ali, because why not? So Nadia said, oh, why should I use Ali's path? It's so much longer. Let's just use the displacement instead. So I just need to cycle for 5 meter instead of 10 meter. So displacement is always the shortest case for distance, right? So, and it is represented by this guy, this symbol, delta R or delta S. Okay, but delta S is more common. Delta R is not that common actually. Delta S is your displacement. Okay, so you can also write it like this. Okay. So displacement has a magnitude, always the shortest distance. Yes, the direction of displacement is from the initial to the final position. This is also like a resultant vector. And guess what? Displacement is a vector. So it's the same thing actually. Okay, so displacement is a vector or a resultant vector. So always from the initial to the end, from the starting to the end. The displacement is independent of the path taken by the motion, which means that it doesn't matter how long my distance is, my displacement will always be the shortest form of the distance. Okay, so that's pretty cool. I like displacement. Okay, so don't have to go over this one. Linear motion, displacement of linear motion. When you have a linear motion, it means that your distance will always be displacement, because when you are moving in linearly, that is always the shortest distance, so that's also the displacement. That is just what it means here. Linear motion in one dimension, distance is equal to displacement. In 1D linear motion, we may represent linear displacement as delta x equals to xf minus x initial, x final minus x initial. Okay, as I mentioned before, displacement is always final minus initial, or initial going towards final. But for the equation, for the delta equation, you always start with the final. So let's say my change in height is always my final height minus my initial height, or let's say my change in distance is always my final distance minus my initial distance. So same case here, the change in displacement is given by final displacement minus initial displacement. Okay, so how do you calculate it? So this is your final position. Let's say the position vector is 0. So this is in the x direction, right? So it's a 10, 0, 0, because I am only moving in the x-axis. The y position is 0, the z position is 0, and my initial position is 5, for example. Okay, so my xf is 10 in the x direction, and my x initial is 5. My delta x is 10 minus 5. So this is my delta x. Hooray! So that's the answer. Okay, but we are always dealing with 2D. So usually this does not matter. Your z value does not matter. So it's usually just 2D. So let's just say this is 5 and 0. And this is 10 and 0. Okay. For our class, I believe we're just going to deal with 2D, not with the z-axis. So your position vector will only involve x and y. Okay. Abaikan yang ni, silap. Okay, so your final displacement is 10, your initial displacement is 5, your delta x, or your delta displacement, or your change in displacement is 10 minus 5, which gives you a 5. Okay. So average velocity. Okay, so average velocity is the rate of change of displacement. The rate of change of displacement. Okay, I'll let you guys take a minute. Absorb that. What does rate mean? What is rate? Can anyone tell me? Time. Kadar. Okay. Over time. That is correct. Okay. Kadar betul. That's in Malay. I am surprised that I know this term because I usually don't learn in Malay. Kadar or over time. What was the other thing? Time. Okay, so time is not specific enough. Over time is good. Kadar is good. So rate is whatever quantity over time. Okay, so for this case, average velocity is whatever quantity, or for this case, it's change in displacement over the change in time. Change of displacement. Let's just write x or s. Change of displacement over the change in time. Why is it a change? Because delta is change. Okay, in case you haven't noticed, I already said delta is change, delta is change. So delta is change. Don't ever get confused. Let me write this one nicely. So this is change. Change in displacement over the change in time. Okay, cool. Okay, I like this equation. It's the simplest. So you cannot not memorize this one. Okay, so average velocity. Okay, what is this guy doing over here? It's called average. Okay, if it's just v like this, it's just velocity. If you have this guy menyibuk kat sini, it's average velocity. Average velocity. Okay. So if I have this guy menyibuk dekat acceleration, it's an average acceleration. Okay, it's just a symbol. Don't panic. Okay, so that is your average velocity. It's the change in displacement over the change in time. So that's pretty easy. So we have instantaneous velocity. While in motion, the rate may be different at each particular instant. It defines the rate of change of displacement at a particular instant, and the equation is given by this guy. So velocity equals to the limit change in time approaches 0, change in displacement over the change in time. Okay, I'm not sure if you have seen this guy yet. Have you? Pernah belajar at maths kot kan? So what do you guys understand by it? What does it mean? It means limit, okay. So, but in layman term, how do you explain to your little brother what limit delta t approaches 0 mean? What does it mean? No, not quite. Try lagi, ada tak lagi jawapan lain? Apa? Menghampiri 0. Macam tu. Any other answers? Boleh juga, but not quite there yet. Di antara no, not more than 0. Okay, what does time approaching 0 mean? What can you understand? Forget this equation. What does time approaching 0 mean? Paling pendek, okay? Lagi? It's almost like a split second, right? You're approaching very, very small. You have, okay, so let's say you have like 1 second is, bayangkan kita tengah tengok lagu Spotify lah, okay? So you have 1 second bar like looking like this, right? Okay, so this 1 second bar, lagu apa yang famous sekarang ni? Super Lonely lah kan? Okay, so this 1 second bar says super lonely like that, right? For example. But I said, oh, what happens when I approach this guy? The change in time to 0. When I try to approach this to 0, I am only taking this part. So what happens to the super lonely verse? It becomes hup, right? I'm not even pronouncing the S, I'm just saying up like that, because at this particular instant, at this time, I'm only saying up because it's super small. The time is super small. It happens like split instant. So that is what it means by when the limit approaches to 0. Does that make sense? Tak lah tu. It does? I'm glad. Because this is a hard concept to explain. But anyways, let me repeat that. You have a Spotify bar that is going 1 second, and this 1 second of the song says super lonely, right? And I said, what happens if I approach time, changing time to 0? Let's say I will take this part only because it is approaching 0, because this is 0.0001, I think. And at this particular instant, at this particular time, the verse saying super lonely only mentions like that. I only hear like a fragment of super lonely. But that is what it means by when you approach changing time to 0. It means that you are observing something happening in split second. Again, you are observing something in split second. The time is too small. It's not even 1 second. It's 0.0001, whatever. But it's super small. Okay? So that is the concept of when limit approaches 0. Don't know if your teacher ever told you that, but that is what it means. Okay, so what happens when we observe velocity in split second? I have a car. My car is red. I am moving at a velocity of 10 meters per second. What happens? Okay, I can't use this example. Tak boleh pakai linear motion. Okay, I have like, I'm going over a road that is very bumpy and whatnot, and my average velocity is 10 meters per second. Slow gila kan? Tak apalah, for the sake of this example. But in split second, when time approaches 0, I want to know what happens. What is my speed at this particular point? Let's say it's V1. I also want to know what is my speed at this particular point, V2. I also want to know my initial velocity here, V3. Okay, so V3, V1, V2 does not necessarily have to be the same as your average velocity. Average is purata, right? But your V1, V2, V3 might not be the same as your purata velocity. That makes sense. So let's say V3 is a 0 because you start at rest. Your V1 is 5 because you have to brake at Seleko. And then here you also have to brake, but you have to brake more so than the first one, so it's 3. But when you calculate the average velocity, it's 10 because you get to speed up here, 20 let's say, you get to speed up here, you get to speed up here. So the average of this entire path, of this entire speed, is actually 10. But when you look at a particular instant, when you are driving, it's not actually 10, but it's a different value, because that is what happens at that particular point. Does that make sense? Is everyone okay with the explanation? Okay ke? Is it too much today? Baru sejam je. How is everyone looking? Let me see. Semua muka macam stress je. Okay lapar. Okay, one hour lagi. Do you guys want a break? 5-minute break? Yes, okay. 7 minutes. Okay, go ahead. Whatever. Eat, drink, whatever. Toilet. Okay, let's come back. Yep. Let's come back at 12:07 minute. Ya, soalan apa? Ya. Apa? Oh, bukan. Dia bukan repeated. Gyroscopic motion. Sekejap Does anyone else have any question selain Lutfi? Lutfi kan? I wouldn't say it's repeating, but it is a type of resisting motion kan? Dia resist rotation. I'm not sure how to classify this. Kejap It's not repeating. Yeah, but it's not repeating. It's not berkala. It just resists orientation, right? Yeah, dia tak ulang-ulang lah. Dia tak ulang-ulang benda yang sama. Dia resist orientation je. Okay, that's interesting. But we won't learn gyroscopic motion in this class. But it's a good example. Thank you. Does anyone else have a question? Yeah. Tak faham yang limit. Macam nak cerita tak faham yang limit. Banyak cerita kejap saya fikir. Do I have a sample? How do I show this? Instantaneous. Velocity. Okay. Berapa dah? Lagi 3 minit. Okay. Sekejap let me try to explain instantaneous again. Okay. First of all, we have displacement. Mana pen? We have displacement. Just as or is delta S, and then the rate of change is okay. Velocity. This is also known as have you guys seen the Instagram video on chapter 2? Tak ada, bukan nak denda, nak tanya je. Dah tengok belum? Laju je jawab. Apa dia? Not clear? Oh, not yet. Okay. Apa tebal sangat benda ni? Oh, okay. So we have instantaneous velocity, whereby our limit of time approaches 0, which gives me velocity of ds dt, which is just the same as delta s of delta t. It's just another form. Okay, tak apalah, letak je lah ds dt. Okay. Is everyone back? Can I start now? Okay. So somebody asked me, can you explain again on what is limit approaching 0, limit of time approaching 0? So let's do a better example lah, I would say. So let's say I have, this is my time, right? So time is in second. I must always label my units, and then this is at time 1, this is at time 2, this is at time 3, time 4, time 5, time 6, time 7, time 8. And I am riding my bicycle tak nak lah, okay lah, bicycle lah. I am riding my bicycle. This is me. Okay, I'm wearing a skirt. So this is me riding a bicycle. So at 1 second, my speed, sorry, kita cakap pasal displacement. My position is 2 meter from the reference point. This is my reference point. Okay, or the origin. And at time 2 second, my, kita letak bawah ni lah, so I can plot it later. At 2 second, my displacement is 5. 3 second, my displacement is 6. At 4 second, my displacement is 10. 5 is, let's say, 11. And at 6, it's a 15. At 17, it's a 16. 18, it's a 20. Let's say. So, what is the formula for average velocity? It is the rate of change over, the change in displacement over the change in time, right? So how would I calculate my velocity here? How would I calculate my velocity here? Average velocity is change in displacement. Oops. What is my change in displacement, guys? Sum of What is my change in displacement? Yes, it is my final minus initial. Oh, shoots. Okay, sorry. So it is SF minus S initial over time final minus time initial. It's just a formula. So plugging in that, my final position is at 20 meter, right? This is my position. Betul tak? I didn't say, oh, I traveled for 20 meter. No, I said this is my position. My position is 20 meter at 8 seconds. So my displacement is 20. My initial was a 0 because that is where I started at 0 seconds, at a 0. And my time final is 8 seconds minus 0 because I started at 0 seconds. So this becomes 20, S is meter, and 8 is second. That is my average velocity. So 20 divided by 8, 2.5 meter per second. What about, now the question asks you, what is the instantaneous velocity at time 4 seconds? What is the instantaneous velocity at time 4 seconds? So I have to calculate the speed at each second, right? Kena kira velocity kat point 1 second, velocity at point 2 second, velocity at point 3 second, which is different because the displacement that I'm going is also different at each second. So kena kira lah. Kena kira. Contoh from here, from 0 second to 1 second, it is 2, so it's 2 meter per second. And then this is a 3 over 1, so I'm going at 3 meter per second. So it's 1 meter per second. And then 4 over, so it's 4 meter per second, and etc. So at 4 second, my speed at that 4 second instant is 4 meter per second. That's my velocity at 4 seconds. It's a 4 meter per second. What if I ask you, what is the instantaneous velocity at 1 second? It's 2. That is what it means. But my average is 2.5. So the average does not necessarily reflect the instantaneous velocity. The instantaneous velocity can be different. Kadang-kadang nak cepat, kadang-kadang nak laju, kadang-kadang nak slow, kadang-kadang nak jalan. Kadang-kadang apa? Terbrake, kadang-kadang terturun bukit, lajulah sikit. So the average is the total displacement over the total time, but the instantaneous is what happens at that particular second, at that particular time. Is that clear? Okay, example basikal tu okay kot saya rasa daripada Spotify. So I think this is clearer. I hope it makes sense. So instantaneous velocity is the speed that you have at that particular second or at that particular instant. That is why it's called instantaneous. Instantaneous velocity. Whereas average velocity is your total displacement over the total time. Okay? So that is it. Oh, acceleration. Okay, acceleration, we have average and also the instantaneous. So the average is the total velocity over the total time, and the instantaneous is when the time approaches 0 or at a particular instant, what is the change in velocity at that particular point. Okay, you can also write it like this. It's the same thing. Oops. Okay, this just means, D just means change. dt, change in time. Same thing. So to conclude, delta x is the change in position. We have seen this using a spring, right? Whereby we said the expansion is called x. So the change in position is x. V, velocity, is delta x over delta t, the change in position over the change in time. Okay, you can also write it like this. This is for instantaneous, and this is for average. Okay, and same case here, average acceleration, and you also have instantaneous acceleration, whereby acceleration is just the change in velocity over the change in time. Okay, example. A motorist drives north for 30 minutes at an average speed of 80 km per hour. Okay, let's draw that later. And then stops for 15 minutes. He then continues east, traveling 130 in 2 hours. What is his average speed? What is his average velocity? Okay, so speed is actually total distance over total time. That is your average speed. Total speed. Total time, Total time. And then you have your velocity, which we have learned in detail just now, unless you are sleeping. Total displacement over the total time. So this guy, displacement, speed is total distance. Okay, so let's solve for this question. So again, remember what is the difference between distance, and what is the difference between distance and displacement, sorry. What am I saying? Kejap Let me put this screen. Hey, kenapa tak nak besar? Okay, tak apalah. Not document. Draw. New document. Okay, so it's making this guy small. Okay, so let's draw next to this guy. Hopefully this is better. Kecilkan sikit ni. Okay, so let's draw this. Draw. Okay, a motorist drives north. So he drives north. That is my north. For 30 minutes at an average of, so number 1 is 30 minutes. That is my delta t, right? My style when solving is I always write down the information. So delta t is 30 minutes, and my average speed or my velocity is 80, sorry, that's average. So average speed is 80 km per hour. So, and then I said it stops for 15 minutes. So number 2, your number 2 section is stopping here for 15 minutes. So number 2, delta t is 15 minutes. The average velocity is 0 because I am stopping. And then for number 3, he then continues east. Goes here, number 3. Traveling 130 km in 2 hours. 130 km, so that's the distance. So it's number 3, delta S or delta X is, tak muat, tulisan besar. Delta S is 180. Okay, I don't like this part. Okay, kita buat kat sini lah. Number 3, delta S is 130 kilometer, and the time, delta T, is 2 hours. Okay, so the question is, what is his average speed, his average velocity? So what is the total distance traveled for this guy? What is the total distance traveled? Can I have names? Can I have volunteers? 170 dah kira dah. Okay, can we solve the first one first? Macam mana nak kira? For number 1, multiply the speed with the time. Do I have to convert this to hours? Yes, so this becomes what? 0.5. Kena buat yang conversion tu. So let's do it. So 80 kilometer. I want to find the distance traveled, right? So this becomes apa tadi? 30 minutes. So it's 1/2 hour. Sorry, it's 2/1. I want to get rid of 1 hour. Get rid of 1 hour. Okay, let me just write this in my. So it's 0.5 hour equal to 30 minutes. Okay, so hour can be cancelled out with hour, which gives me 80 kilometer. Sorry, kita nak kira ni lah. Kita nak kira distance, bukan nak convert. So this is just 0.5 hour. So 80 kilometer per hour times 0.5 hour. Get rid of the hour, gives me 40 kilometer. Okay, I'm not trying to convert 80 kilometer per hour to 80 kilometer per minute. I'm trying to find the kilometer, so I have to get rid of the hour. Okay, hope that's clear. Then number 2, no distance traveled. So this guy is my delta x number 1, right? My delta x number 2 is a 0. Okay, this is delta x number 1. Hey, I wish I can write lagi neater. Okay, and then delta x number 3 is 130. So your total distance is 40 kilometer plus 0 plus 130 kilometer. So it gives me 170 kilometer. So it's correct. It's 170 kilometer. So what is his average speed? What is the total time? Total time is 30 minutes plus 15 time, bukan distance, plus with the 15. Why is it not working? Draw 15 minutes plus 2 hours. 2 hours in minutes is 120 minutes. So that gives me 30 plus 15 plus 120, 165 minutes. Okay. Insert image. Let's see. Okay, never mind. Okay, so I have my total distance, which is 170 kilometer, and then I have my total time, which is 165 minutes. Okay, so what is my average speed? Usually we need to convert this to hours divided by 60. So this becomes 2.75 hours, because our guy over here is in kilometer per hour, right? So I'm just following the question, but if you want to stay as minutes, that's fine. So speed is total distance over total time, which gives me 170 kilometer over 2.75 hours, which is, yes, 61.82 kilometer per hour. That is my speed. Okay, let's do the average velocity pula. What is the formula for average velocity? It's total displacement, right? So for total displacement, we need to find the displacement lah. Tadi we are given the distance. So this was berapa tadi? 40, right? 40 km. Kita dah kira tadi distance dia. It was 40 for x1. And then we stopped 15 minutes. Tak ada apa-apa kat sini. And then we went to the east for 130 km. So the resultant of this, or my displacement, is from the initial to the end. So that is my displacement. So I draw a line like that. I can solve this length by Pythagoras. So what is that? This is my hypotenuse. So the length, let's just say the length is A. Okay, so A squared is 130 plus 40 squared. So A is square root of that is 136, right? Did everyone get the same answer? Okay, 0, 1 kilometer. So that is my displacement. Oh, I should have just said X here. Okay, sebab kita punya equation X. Okay, so average velocity is, let's write that down. Average velocity is just change in displacement over the change in time. So we know our displacement is 136.01 kilometer, and then our change in time is 2.75 hours, right? So that is is it 46 or 45? 46, eh? Okay. 46 kilometer per hour. Okay, so that is the difference between speed and velocity. Need to know the difference between distance and displacement. Okay, so that is it. And then we have acceleration. Okay, tutup sekejap. Okay, and then we have uniformly accelerated linear motion. So for this chapter, we are assuming acceleration is always constant. Kejap, tak jugalah. Tu chapter projectile. Sorry, that's a subchapter. So acceleration can be constant, or it can be increasing, or it can be decreasing. Kalau velocity is increasing, okay, let me write that down. If your velocity is increasing, okay, for example, you started at 1 meter per second, and then 2 meter per second, and then 3 meter per second. This means that your acceleration is positive. If your velocity keeps decreasing, it keeps on decreasing. Dia macam kita brake, kita punya speed makin menurun kan? So let's say I started with a 50 meter per second, I braked my car, so it becomes slower, so it becomes 30 meter per second, 10 meter per second. So my velocity is decreasing. This is actually negative acceleration. Okay, that is what acceleration that is positive and negative means. Means that your velocity is either increasing or it's either decreasing. If your acceleration is a constant, if A is a constant, your velocity is the same at all points. Kejap. No, it's increasing steadily, sorry. V is increasing steadily or decreasing steadily. When A is a 0, V is the same at all points. Oh, I hate writing like this. Okay, so when A is a 0, V is the same at all points. We will see this example, don't worry. Okay, so U is your initial velocity. This is the sign for it. Initial, V. Initial velocity is known as U. This is final velocity. Okay, so average acceleration is v minus u, because why? Final always minus the initial over time. So this equation, when you bring time over here, it gives you at, right? So at equals to v minus u. And you want to make v as your subject. So v equals to, you bring u over here, so u plus at. This is your first equation for your kinematic equation. Apa? Kinematic. Panggil dia, forgot. What is it called? Kinematic linear equation. I think that's what it's called. Kinematic equation. Yep. So that is your first equation. From your average acceleration punya equation, you bring the t over here, you bring the u over here, you get v equals to u plus at. This is the first guy. And then from your average velocity equation, which is displacement over time, which is also the initial velocity plus the final velocity, you divide it by 2, because average velocity is just purata, right? So you can divide it by 2, the initial and the final. You substitute these two guys together, you get your second equation. Displacement equals to 1 over 2 u plus v t. You have to memorize these equations. So that's your second one. Okay, and then substituting 1 into 2 gives you equation number 3, s equals to ut. U is your initial velocity plus 1 over 2 at squared. A is your acceleration, s is your distance or displacement. And then if you substitute 1 into 3, you get v squared equals to u squared plus 1 over 2 as. Now, what is the purpose of having 4 equations for the same thing? There's a reason for that. Okay, so for equation v equals to u plus at, when you have the value for u, you have the value for v, you have the value for t, you can solve for the value of a. But this equation will not help you solve for s. And the same thing, if you have the value for v, for the value for t, the value for a, you can solve for the value of u using this equation. Okay, so this equation, they cover different quantities lah, different values. So all these equations you can use for u, all these equations you can use for v except this guy. This equation you can use for s except this guy, and okay, semua boleh kecuali this guy. Okay, but you need to know lah, you will be more familiar with these equations later on when you are solving for projectile motion and linear, apa tu nama dia, free fall. But basically you have to memorize these equations, okay, because you will use this up until next semester. Hooray! Kejap, berapa minit lagi? Setengah jam. Okay, so problem solving strategy. Read and understand the question, visualize the situation. In some cases, you may need to split the motion into sections. Okay, we will go through this. What does it mean by splitting the motion into sections? Draw a straight line to represent linear motion. Fine, that's easy. Indicate the initial and final position. Okay, in your diagram, indicate the initial velocity, final velocity, acceleration, time, interval, this blah blah blah. Okay, don't worry, we'll do that. Determine the known and unknown values. Use the relevant kinematic equation. This is the part where you screw up. This is where you screw up basically. But don't screw up, okay? The way you can not screw up is by memorizing these equations. Okay? So because it's actually easy once you have it down. State your final answer. Do not forget the units as always. Units is important. Without the unit, I will deduct 1 mark from your answer. Okay, so let's go over this example. It is claimed that the Ferrari car can speed up from rest, reach its top speed of 210 km per hour in 100 seconds on a straight track. What is its average acceleration in meter per second? Now remember, these equations, when we have A, it is actually average acceleration. Okay, And the V is also average velocity. So whenever they have average acceleration, average velocity in the question, you can use kinematic equation. Now let's write that down somewhere. Let's do this first example for kinematic. Kejap, nak kecilkan ni macam mana? Kejap. Okay. Is everyone still with me? Are you guys sleepy? Terkejut tak tengok soalan dia? What a question to ask, right? Okay, never mind. Don't answer that. Okay, so let's besarkan yang ni. Hope this is readable. Okay, let's draw it. Okay, I'm gonna try my best to draw this. It is claimed that the Ferrari car can speed up from rest. Now, remember we have u, our initial velocity, right? Let me just write that down because this is your first time seeing it. This is initial velocity. What is your initial velocity? I'm gonna give you a hint. The Ferrari car can speed up from rest. What is rest? 0, right? So from rest just simply means 0. It starts from sleeping basically. You're starting from rest, starting from sleeping. Bangun tidur, oh ada velocity dah, macam tu lah. Okay, that's your initial velocity. And then reach its top speed of 210 km per hour in 100 seconds. So delta t is 100 second, right? And then we have v, which is the top speed, is 210 km per hour. So we have u, our initial velocity, which is 0 km per hour. Delta t is 100 second, which is the time from the initial to the final. And then we have v, which is 210 km per hour. Right. How far does it travel? What is the average acceleration? So it's asking you, what is A? Solve for A in meter per second. Mengada-ngada pula nak tukar-tukar. Okay, so it's meter per second. How far does it travel during this time? How far does it travel? So that is actually distance or displacement. So you need to find the S. Using these values, what equation can we use? Let's look back. Okay, which equation? 1, 2, 3, or 4? We want to solve for A. Equation 1, right? So equation 1 says you can't solve mana pergi ni? Oh, you can't solve for S, but you can solve for A if you have U, V, and T. Right, we have U, V, and T. That's good. So let's draw that one. So V equals to U plus AT. So V is 210. That is in kilometer per hour. U is 0 plus A, we don't know. We are finding A, and time is in seconds. So can I put this time in seconds in this equation? Or do I need to convert it to minutes? Hello? Is anyone there? Do I have to convert my time? Or do I have to convert my velocity? Or do I not do anything? No one? Okay, Heidi Jimin. Tak dengar? Putus-putus ke? Dah okey dah? Saya terkeluar. Can you guys hear me now? Oh, putus. Sekarang okey? Okay, nak dengar balik. Okay. So, from the initial velocity part mana yang putus tu? Okay, daripada awal je lah. Okay, so we have the initial velocity because we started from rest. Okay, so from rest just means u equals to 0. And then we have 100 second as the time. Sekejap, kita tengok balik gambar soalan. So, can speed up from rest. So, from rest, u is 0. And its top speed or its final velocity is 210 km per hour in 100 seconds. So, the change in time is 100 seconds. On a straight track. So it's a linear motion. So we don't have to deal with x and y. It's just in the x. What is its average acceleration? So the question asks you, what is a? In meter per second. How far does it travel during this time? What is s? Because s is distance or s is displacement. So one of you guys told me that v, the equation that we can use using these values that we have is equation number 1, because we have v, we have u, we have t, we don't have a, and we want to solve for a. So that is why we are using equation number 1. So we are using equation number 1 because we want to solve for a, and we have v, u, and t. Now my question here is, my velocity is in kilometer per hour and my time is in 100 seconds. Can I use this equation? Like this. What should I do? Okay, why do you want to convert the velocity instead of the time? Yes, so always try to find the easiest way to do it. The answer, the question wants you to answer in meter per second. So let's convert the velocity. So let's do that here. 210 kilometer per hour. 1 meter is 1000 kilo. 1000 meter is 1 kilometer. Terbalik. So 1000 meter is 1 kilometer. I want to get rid of my kilometer. I also want to get rid of my hour. So it should be up here, which is equal to 3600 seconds. So this will give me what? 1000 58.33. Yes, thank you. Betul. Point per second. So now it's in second. This guy is in second, so I am good to go. 58.33 meter per second. 0 plus a 100. So now I don't have to care about the sign. I don't have to care about the units because they are same. I just know this is second, meter per second. Okay, so solving for a gives me 58.33 over 100. That is 0.58 meter per second squared. This guy is a meter per second. This guy is a second. So I have 2 per second. Meter per second squared. That is my answer. It's a positive. What does it mean when my acceleration is a positive? Am I stuck again? What does it mean when my acceleration is a positive? I told you just now. The velocity increases. Is that the case? It started from 0 and it reaches a final speed of 210. Yes, it increases. Okay. And then the answer says, the question says, what is the distance traveled? What is the distance traveled? Now, what is the equation that we can use now? I want to find S. So equation number 1, I can't use that because it doesn't solve for S. Which equation is the most suitable? Equation 2. What other equation I can use? Semua boleh pakai kan? Except number 1, right? Let's try that. Let's try all 3. File, new document. Okay, so let's try with equation number 2. Okay, so equation number 2 says S, or the distance, is 1/2 u plus v t. And 1/2, u is a 0. This guy is a 210, but we needed to convert that to meter, which was, what was it? 558.33 kan? Betul tak? 2 meter per second kan? Okay, so this is a 100-second guy. So S gives me 8.33 times 100 divided by 2. 2.92. Okay, that is using your second equation. Third equation, S equals to ut plus 1/2 at squared. Your u is a 0, so yay, less work. Your a was, what was it? Forgot already. 0.58 times 100 squared. Kenapa ada plus sign kat sini? Sorry about that. We 1/2. Okay. Okay. So this becomes 100 squared times 0.58 divided by 2. Kenapa dia jadi macam 2.9? Oh, betul lah. 2.9. So this gives me 2.90 actually. Meter. And for number 4 equation, v squared equals to u squared plus 2as. So u is a 0, that's awesome. 2 is apa tadi? 0.58, and s is, we want to solve it, v is 200, sorry, what was it? 58.33, right? 58.33 squared. Don't forget the square. 58.33 squared divided by 2 times 0.58 gives me the S, which is, good job, 2.93. Kenapa dia kurang desimal ni? What am I missing here? 58.33 u 2as. Oh, 100. Forgot the 100. Sorry. Okay, I am missing some decimal points here. Kejap. Let me do it again. V is 58.33. U is a 0. Square plus 2as. 2, and then A is 0.58, and S is, we are solving for that. Okay, I am missing some decimal. Did I calculate the A correctly? Sekejap, tengok balik. Check balik. So 210 ni betul. 1000. Sekejap It should be the same. The answer should be the same for all. So A is V equals to U plus AT. So 58.33 divided by 100. Okay, so number 4. What am I missing here? V squared plus 2AS. Missing something. Okay, so I will let you guys know what is going on here. It should be the same. I am missing something here. Most likely I forgot something. Okay, so let's KIV this one first. Okay, but the answer should be the same. So here we got 2.92, which is okay. And then we had 2.90. There is a slight difference in decimal points, which is understandable because this guy is 58.33, but for this guy I used only 0.58 only. But if I were to be more precise, I would say this is 0.5833, and the answer should be the same. 0.5833 times 100 squared. Yep. Sorry? Berapa? Saya yang tersilap tulis kat atas ni kan? Okay. So betul lah, semua jawapan betul. Okay, let me erase that. So yang ni jadi 2000 berapa? 196. Is that right? Am I doing this correctly, guys? You guys need to check me. Okay. So this is also 2916.5 meter. Okay, now it's okay, 58.33 squared divided by 2 times 0.58, right? 2933. Okay, if I were to be more precise, I would put this here. 0.33 squared divided by 2 times 0.5833. So you get 2916.5 meter. Okay, so here, whichever equation that you decide to use, it should be the same. If you want to check back on your answers like I did and I proved myself wrong, so you are free to do that. Okay, so it should be the same, the answer. Okay, so that was that. Okay. So that's a pretty cool equation, if I must say. Okay, how many minutes are left? 8 minutes. What do I want to cover quickly? Okay, acceleration due to gravity. Okay, let's just go over this one really quickly and then we will end class, okay? So acceleration due to gravity. Acceleration is always going downwards. Gravity is always pointing downwards towards Earth. And this is symbolized by G. So gravity is a type of acceleration and it is a constant. The G is always directed downward, which is why we put a negative sign there. It's not the negative, it doesn't mean that the velocity, it's a constant acceleration towards Earth, which means that if I am dropping a ball, okay, remember that I told you minus acceleration means that velocity keeps decreasing, right? Imagine me, I have a ball on the table, okay, and my cat name is Oyen, whatever the name is, decides to push the ball off the table, right? So it starts from rest because it was literally not doing anything there. It was minding its own business, and suddenly Oyen comes and decides to push the ball off the table. So it starts from rest, U is a 0, and it goes down due to gravity, whereby it is minus 9.81 meter per second. So when it reaches, dia belum touch the ground lagi, this is the point that I'm talking about. It's not there yet, it's not on the lantai, it's not on the ground, but at this point the velocity is, let's say, minus 25 meter per second. So minus acceleration means that velocity keeps decreasing. So yes, it indeed kept on decreasing. It started from a 0 and it decreased to a minus 25 meter per second. Okay, so that is why acceleration is a negative. It will keep on decreasing the velocity. So if your velocity starts from a positive, it will become less. So let's say the ball starts from a velocity of 25 meter per second, and upon reaching the ground, it becomes a 0 because it is going through negative acceleration, which means that the velocity keeps on decreasing. So this guy is the initial and the final is a 0. This is also another case. So again, you can start from a 0, it becomes a negative. You can start from a positive value, it becomes smaller, or it becomes a 0. That is what it means by negative acceleration. Velocity keeps decreasing. And the value for acceleration is 9.81. It's a constant. Previously, we have talked about linear motion, right? I was talking about my bicycle. I was moving in the right direction or in the left direction. But for free fall, we will talk about S as h, whereby displacement or distance as height. And height can be positive, whereby you are going higher, and you can also have a negative height, whereby you are going downwards. You start from here, you end here, your height is a negative, you are going down. You start from the bottom, you end here, your height is a positive, you are going up. But your g, or your acceleration, is always a negative because A is always pointing towards the earth, downwards. Okay, so that is it for class today. I will see you on, what day is it? See you on Friday. Any questions before we end class? No? Everyone okay? Yep. Apa? Skip banyak? Okay, sure. I will send you the recording on YouTube as always. I hope it's working. Okay, so anything else?